All right, guys, today we are going to talk about how to predict the products of a chemical reaction. In order to do that, we need to understand what happens during a reaction. In a chemical reaction, bonds break, the atoms rearrange, and new substances are formed. The key is to make sure that those new substances are stable. Stability depends on whether we have an element or whether we have a compound. If you have an ionic compound, it's important to remember that stability means that we have to zero out the charges. If it is an element, we don't have to worry about charges, but instead we have to check to see if it is one of our 7 diatomic elements. If we break down the word diatomic, di means 2 atomic atoms, so we're looking for 2 atoms that bond together in order to make a molecule. An easy example of this that we're all familiar with is oxygen. The oxygen in the air that we breathe is not O. Whenever there's O, or oxygen, in its elemental form, it will always exist as O2. So when we say oxygen, we're really talking about O2. There are 7 elements that are like this. Those 7 elements are H2, O2, N2, Cl2, F2, I2, and Br2. All right, let's work through a few problems together. So a really helpful reminder is that metals on the periodic table to the left of the staircase will always carry a positive charge when they're in a compound. Our nonmetals are to the right of the staircase, and those will always carry a negative charge when they are in a compound. So let's start by determining if we have an element or a compound. The fact that I have 2 capital letters in here means that I have 2 or more elements joined together. That makes this a compound. My potassium is a single element all by itself. When I am going to predict the products, it's important to remember that in a chemical reaction, I need to make something new. But that something new has to come from the atoms that we start with. We can't put a magnesium atom in and get a gold atom out. Instead, we're going to have to rearrange the atoms that went in on the reactant side. I suggest starting this problem by determining if the element is a metal or a nonmetal. A metal, like magnesium, will carry a positive charge when it's in a compound, and chlorine, a nonmetal, will carry a negative. K is also a metal, so when it's in a compound, it will carry a positive charge. Now, we can never put 2 positives together or 2 negatives together and get a stable compound. Instead, we are going to have to pair a positive with a negative, but we want a different pairing than we started with. The only option here is to put our K and our Cl together as our first product. When I put K and Cl together, notice that I wrote the K first. The positive, or the metal, is always written first in a compound. Now I need to check their specific charges. Yes, I know K is positive, but from the periodic table, I know it's specifically +1 and chlorine is -1. Because we have a +1 and a -1, this balances out, meaning that KCl is happy as written. I'm going to have a second product. The magnesium that was once paired with chlorine is now going to be kicked out and standing on its own as just Mg. Mg is an element. When we have an element, we don't have to worry about the charge, but instead we're going to check our diatomic list to see if it's on there. Magnesium is not, so that means it's stable as is. Now that all of my elements and compounds are stable, now I have to show that mass is conserved. At this point, I can no longer change subscripts, but I can add coefficients in order to make sure that every atom that went in on the reactant side came back out on the product side. If you need a quick tutorial on how to balance chemical reactions, check out my video that's linked above. When this reaction is balanced, we have a coefficient of 2 in front of the potassium and 2 in front of the potassium chloride. Now we have a correctly balanced equation. Every single reactant and product is stable or happy, and second, all of the atoms that went in came back out. Let's look at a second example. I have Ca3n reacting with Na2O. These are both compounds. I know that they're compounds because they have more than one element in them. When I have a compound, I am going to check to see if it's a metal or a nonmetal. Remember that the metals are written first, and therefore the positive charge will be first. Nitrogen is a nonmetal and negative. Sodium has a positive charge since it's a metal, and oxygen is negative. Now I need to figure out how I can rearrange these atoms and pair them up differently, yet still have them be stable. I'm going to start with my calcium. I cannot pair the calcium with the sodium because I can't put 2 positives together, but I can pair the calcium with the oxygen to make something new. When I do that, it's a compound and I need to check those charges. I know calcium's positive, but from the periodic table, it is specifically a +2 charge. Oxygen is -2, So that is stable as written. Everybody's happy. Now I'm going to have a second product. That second product is going to be my other positive-negative combination. I'm going to put N with the Na. But remember that we have to write the metal or the positive charge first. So I'm going to put the Na first and then the N. Every time I write a compound's formula, I have to check those charges. From the periodic table, I know Na is +1 and nitrogen is -3. In order for this to be stable, it's going to have to be Na3N. Now that everybody's stable, now I'm going to add coefficients in order to show the conservation of mass. Again, we should always make sure they're stable first, coefficients second. When this is balanced, I will have a 1 in front of the calcium nitrate, or nothing is written, a 3, a 3, and a 2. So this is a properly balanced equation because everybody is happy and it is balanced. Let's take a look at a third example. This time I have only one reactant. That one reactant is a compound. I know that because I have 2 capital letters. When I have a compound and it's ionic, the first will always be the metal or positive, and the second element will always be the negative charge. I don't really have anybody else to pair my Mg and my O with, so what's going to happen here is that the Mg and the O are going to have to separate. That's the only way that I can make something new, and every chemical reaction results in the creation of a new substance. So I'm going to separate my Mg and my O into Mg plus O. Since Mg is an element, I don't have to worry about its charges, but I do have to check to see if it's diatomic. It is not on my diatomic list, so it's perfectly okay to leave this as Mg. It's stable, it's happy. But when I go to O, which is another element, O is on my diatomic list, which means that it will only exist as O2. Now that everybody's stable or happy, now I'm going to add coefficients in order to show that every atom that went in came back out. My properly balanced equation is 2MgO produces 2 Mgs plus 1 O2. Let's take a look at one last example. This example looks harder than the previous ones because it contains polyatomic ions, but our process is going to be exactly the same. Na2SO4 is a compound. I know that because I have 3 capital letters. The Na is the positive or the metal, and the SO4 is a polyatomic ion. The SO4 sticks together, and that whole thing carries a negative charge. My aluminum is a metal, and therefore carries a positive charge. My nitrate, again, polyatomic ion, and that will carry a negative charge. Now I need to pair them up differently than they're currently paired, but I have to make sure they're still stable. Again, I can't put 2 positives together or 2 negatives. So let's start with the sodium. The only other thing that the sodium could pair with to be stable, besides the SO4, would be the NO3. I'm going to put the Na and the NO3 together. Notice when I brought the polyatomic ion over, NO3 sticks together. The polyatomic ion nitrate has the formula NO3, so I need the 3 to come over, or the subscript. After I've written the new positive and negative, I'm going to check their charges from the periodic table. Sodium is +1. Nitrate, the polyatomic ion, carries a -1 charge. That means that one Na will make one NO3 happy, and this is stable as written. My second product is going to have the sulfate, or SO4, and the aluminum. But remember, we have to write the aluminum first and the SO4 second. Aluminum carries a +3 charge, and the polyatomic ion sulfate carries a -2 charge. This is not happy as written. We have to make sure that we zero this compound out, and we can do so by putting a 2 here and a 3 here. Once all of my elements and compounds are happy, I'm going to get rid of the charges, and now I need to balance it to show the conservation of mass. When this is balanced, all of the individual compounds should be stable or zeroed out, and every atom that went in should come back out. This is a properly balanced equation. I hope that helped with how to predict products. Thanks for watching, and please check out my other videos.